He's given me the thumbs up. Hi everyone, yes, my name's Rogage. I'm an associate professor of computer science at Northumbria. Hiding up the back is my co-author Pablo, who's an associate prof in construction management, construction project management, as is Gledson, and Bahriye is an assistant professor in architecture. So we're certainly a multidisciplinary team on this particular paper. And I'm sorry I'm not going to tell you anything really groundbreaking here. And fortunately, Mustafa's set up the problem that underpins what we're trying to address. I think what we are trying to do is look at this from a slightly different lens here. So hopefully you'll get some insights from a different perspective. I should say this is very early stage research, like right at the beginning. So I think it creates more questions and more opportunities than it does present any answers. But one of the things I do in computer science is think about and teach my students this idea of more sustainable approaches to developing digital solutions, whether that be creating more efficient code or thinking about storing data in more efficient ways or processing data using more carbon efficient techniques. And whilst what we're looking at today isn't going to solve this problem in the construction around sort of the carbon emissions that it produces, I think it's a nice start to think about the kind of impact of digital transformation on carbon emissions in our sector, as it were. So Nick, I'm not going to solve any problems on this today. I know you're going to either ask questions or make comments about that. But there has been a lot of work done around addressing the carbon problem. And, there's some fantastic work around digitalising the construction activities across a construction life cycle. But as Mustafa has just said, quite often we're not sure why we're doing that or what the purpose of that is. And we're doing it because we think we should be doing it, or we're just trying it because we're early adopters of the innovation and we're trying to understand the benefits and how it can be used. But digitalisation comes with a consequence as well. So often throughout the building life cycle, there are lots of data exchanges that take place. And when I produced this paper last year, we were looking at many thousands of data exchanges, but actually more recently I've found out we're doing millions of data exchanges across some large infrastructure projects, which is just bonkers. And everybody across that supply chain has different data requirements, different reasons and purposes for using that data, and sometimes that data doesn't migrate through from one stage to the next, so that ends up in a lot of recreating of data and data redundancy and duplication. Now this website here, Data Never Sleeps, does some kind of analysis on data and provides some lovely statistics here around data. And generally, so not in the construction domain, in 2021, and bearing in mind we're 4 years ahead of that now, so this is going to be even bigger now, we were creating 2.5 billion gigabytes of data every day. So that's data across everything we do around digitalisation and data. And where that data is stored, how it's transmitted, and the way it's captured accounts for 700 million tonnes of CO2 emissions every year. And to put that into context, the aviation industry is responsible for 720 million tonnes of CO2 a year. So, and that again, that's in 2021, so that those numbers will have changed a little bit since then. But we have a problem. We're creating a lot of CO2 emissions, we're affecting the environment with the way that we are digitising the world, as it were. Now, more than half of the data collected and stored is never used or reused. And so Jackson and Hodgkinson did some research around that. Any data that's not collected and reused beyond the purpose that it was originally captured is thought of as dark data. And that's sitting somewhere on a server, just, sitting, consuming energy, consuming resources somewhere out there. And these guys, Snyder et al., did a study of some large infrastructure projects, and And they looked at how much data was being generated. I mean, 130 million emails was typical for a large infrastructure project. Now, I feel like I get 130 million emails a day. I don't know about you lot. And more often than not, probably only 2 are actually worth reading or responding to. The other 128 million didn't need to be sent, or however many it was. Also, they found that, there's a lot of documents being produced and a lot of digital workflows here, so the numbers speak for themselves. But they found that out of all of that data, approximately only 4.5% of this data is used. So 95.5% of the data generated in the construction industry on these large infrastructure projects that were analysed is just not being used, which is a shame, really. But it does highlight problems with the ways that we're requesting data, generating data, sharing data, and it not only does it mean that we need to be better educated about the purpose of that data and the purpose of digitalisation, but also we need to understand the impact of that as well. So that's where we come in. We were trying to understand the carbon footprint of digital design workflows, and we had a look at what's out there. I mean, there's loads of work out there on decarbonising everything, to be honest, but there's work on decarbonising workflows. There's a lot around measuring the carbon footprint of sort of machine learning algorithms and websites. You can even calculate, the carbon footprint of driving your car from A to B, for example. But what we couldn't find is something that specifically looked at digital design processes in the construction domain, and how do we capture the carbon footprint of that. So we did a little bit of research to see what was out there already. So again, we refer back to these guys, Jackson and Hodgkinson, are doing some work in this area. They created this digital carbon ladder. Does this work on here? No. So at the bottom here, I know it's hard to see on the screen, but essentially that's saying the first thing you do is you look at your data set. It doesn't matter what your data set is. It could be medical data, architectural drawings, financial data, utilities data, whatever it is. And then you think about that data set. Do you import that data set? Do you create it, or do you aggregate it from different data sets? And then you look at the size of that data set. And that has a carbon impact just on its own like that. Then what are you doing with that data? Are you kind of batch sort of pulling it from somewhere? Are you collecting real-time sensor data or near to real-time data? Or is it just a static file that never ever changes, for example? Then where is it hosted? Is it hosted in-house on your PC or on the cloud somewhere, for example? And all that has a carbon impact as well. Then, what do you do with that data? Do you just produce a PDF and that's it? Or do you perform some analytics? Maybe you've got a Power BI dashboard. We love Power BI in the construction industry. We love doing data analytics on our data. And that has a carbon impact as well. Now, for the various combinations of those things on that ladder, they do actually provide different formulas for calculating the carbon impact. We only actually use one of them. I'll explain why in a minute. But there are different calculations in there for that. The next thing we did is said, let's think about the digital design process. And at each stage throughout the project life cycle, from the project initiation through to sort of handover of the design, we're producing all these data outputs that you can see across the bottom here. So responsibility matrix, architectural design drawings, MEP drawings, etc., etc. So we thought, let's take that digital carbon footprint, which is exactly what you can see up the left, that data carbon ladder even, and let's map that onto the design processes across the top here. And let's test it out. So we did some really basic testing, which is why I'm emphasising this is early stage research. We took some typical files from a design process, and we mapped it against that data carbon ladder. So the first thing is a site scan survey created on premise. It's only 5 gigabytes. It's just used for information, and it produces around 38 kilograms of CO2. As I said, at this stage, we're not making any big claims about how we're going to reduce carbon emissions. And responsibility matrix, really lightweight Excel file, really, really minuscule amount of carbon emissions. Then we've got an architect's concept design and point cloud survey, and again, really small amounts of CO2 emissions there. But bear in mind, this is just a snapshot of data at a point in time. Clearly, in the real world, there'll be many iterations of that architect's drawing. You know, there are lots more data outputs that are generated. We just wanted to see, would this framework work? And if it did, how would we implement it? And how might it work? So I guess, as I said at the beginning, I'm not claiming anything groundbreaking here. It does provide a framework for trying to calculate your carbon footprint. To actually utilise that in the real world would be an incredibly laborious and manual process. So clearly we need to look at ways of automating that. It wouldn't be difficult to write a script to take a CDE, for example, and analyse the files across there and analyse the number of iterations of communications in a digital workflow, and then do some formula to work out the carbon footprint of that. I think more interestingly, it kind of presents us a foundation for developing this research further. There's some lots of exciting things that we've done beyond this, and we're continuing to work on and create ideas around what the potential is going forward for this. So thanks. Any questions?